Okay, now let's fit a multiple linear regression. And to fit that, we use the sklearn linear models. From that, we import linear regression and we fit the model. So we fit it using X-train and Y-train. And then we can get the coefficient values, the intercepts, and other coefficients. So basically, we have this array. To examine the coefficients better, I put it to a data frame. And to this data frame, I get a list of the coefficients and I append the intercept coefficient. And I put these variable names. They are the X-train columns. And I also, for variable names, I put the intercept. And then I built this small data frame for coefficients. And then the column heading will be coefficients. So, right, now we get the coefficient values to predict our temperature. And we can also use stat models like what we did with simple linear regression. So remember I told you that you need to add the constant when you use stat models. So we add the constant and then we fit sm.ols, the training and the training y and x, and then we fit the model and we get the model summary. Okay, so the coefficients that we have here are exactly the coefficients we have here using two models. Okay, so let's predict it for the test set now. So previously we predicted for the training set itself. Now let's predict it for the test set. So I call it as y predict, and that is LR. LR is the model that we use. So LR.predict, and we pass the X test data frame. So we predict it, and for residuals, it is the difference between y test and y predict. Get that. Now let's visualize the predictions versus the actual values. So I use the plotly scatter function, and the x value is the y test, that is our predicted values, and our y variable is, sorry, this is our actual values and these are our predicted values. Okay, so now we have a nice prediction of actuals. So we have nice linear line. So that means when the actual value is somewhere here, the predictions are here. It's basically when the value is 60, the prediction is also around 60. So we see a nice line here. But instead of visualizations, let's go into our evaluation measures and let's use root mean square error on the test set. So we pass the y test, that's the actual values and the predicted values, and we get the root mean square error. Right, so now we have a root mean square error of 2.13. That's pretty good, right? And okay, so now we have fitted a multiple linear regression. And when it comes to multiple linear regression, we have different linear regression assumptions. So I have put the linear regression assumptions here, but I will not go through it now. I have all the codes here, so, and it will be shared with you, so you can go through it at your own time. And you can see what we can do when the assumptions are not met. So we have everything written here, and we have the visualizations that you need to do. And I also suggest the tests that you can look up to for each of the regression assumptions. So I'll skip this part because we might not have time for the rest of it if we go through this. Okay. Right, so I'll skip this and I'll move to regression trees. So does anyone have questions on multiple linear regression? Okay, looks like no questions. Right, I'll move to regression trees. Okay, now previously we wanted to fit a straight line to the data, but straight lines don't really work on all the scenarios. So take a look at this data here. So we have the time and the temperature. What if we fit this? If you fit this straight line, you see there's going to be a lot of error. So to avoid, we cannot really fit this straight line, and instead of that, what if we split the data into different parts and then we make our predictions? So for something like that, when we cannot fit a linear model, we can use regression trees. So a regression tree is a hierarchical structure, and it consists of nodes and leaves. And these nodes are connected by edges. So for example, I have plotted this one. So let's say we want to predict the temperature, and we ask the question, is dew point average is less than 40? If it's yes, we ask the question again, is it less than 20? Or if it's more than 40, we can maybe the model will say, okay, the temperature is going to be 5. So basically in regression trees, you start from a node and then you ask a question and then you do a binary partition. So it's two parts. It moves either this way or this way. And then we can finally predict the temperature values. So those are the ones in the leaf nodes. And considering this example here, you can ask the question, is time less than 5? If it's less than 5, we can put the mean value of this one. Or if the value is greater than 5, you can ask, is it less than 7? And then you will get the mean of this. So something like that. And let's see how we can build a regression tree. Okay, so one second. So we have this data set here, and we have the time values and we have the temperatures. So first we sort the x and y values based on our x variables, so based on our time. And it's already sorted. So we start from 1, it goes up to 10. And the temperature values are the values corresponding to that time. So then we take the first and the second value of x and we take the average. So we take the first and the second value. So that's 2 and that's 1 here. And we take the average, and that's going to be 1.5. So using that average value, we split the data set into two parts. So these are the two parts. Okay. Then we take the mean square error of the y variable resulting from that split. So here we can take the y variable is going to be 1, and the value that we predict is the mean of that. So it's basically 1 minus 1, and in this part, the mean square error is 0, and similarly we can continue for this and at these two. So we have a mean square error for each of these splits. So then we repeat the process until the last value of x. So we repeat the process until the last value, and in each split, we get a mean square error. So now we have, if we have n number of data points, we have n minus 1 splits and MSE values resulting in each split. So I don't really have a plot here, but if you plot the split versus the mean square error, then you can find this sweet spot where it gives the lowest mean square error. So then we select the split that results in the lowest mean square error as our root node. And then we divide the data set into two parts. Let's say our root node is this one, and then we split it into two parts. And then we repeat the process on these parts of the data until we build the tree. So you might have a problem. Where do we stop this tree? So there are different conditions to stop it, and one of the ways to stop it is to think about how many samples are going to be there in a leaf. Say you can tell the model, okay, if you have 5 samples in one node, you have to stop it. So then it will stop here. Okay, now let's move into our Colab and see how we can build a regression tree. Okay, so now we get from sklearn tree, we import the decision tree regressor. And then remember we added a constant column. So we drop that constant column from X, and that we call it as X-train. And then we fit the model using this decision tree regressor. So if you hover on top of the values, you can see what this function has, the different parameters of the function. So now you see the splitter is at best, the maximum depth is none, the minimum sample split is 2, and minimum sample leaves is 1. So these are different stopping conditions. You can change that if you want. So here I have set minimum sample leaves to 5, and I use 42 to repeat, and then I fit the model for X train and the Y train. Okay, now we have a fitted model. Let's make some predictions. So I call it Y predict decision trees, and I use the X test, our testing data set, the testing X data set, and I predict the values. So similar to what we did before, let's draw a scatter plot between our actual predictions. Okay, we have a similar scatter plot like we got from linear regression. So it's basically, it looks like a good prediction, and before relying on the visualization, let's look at our value. It's 2.90. So what did we get from linear regression? Let's see. Okay, from linear regression, we got 2.13. And from the decision tree, we have the regression tree, we have 2.90. So we have our regression tree has is still a little worse than our previous model. Okay, we can also visualize the plot, visualize the tree here. Takes some time. So basically you will see here, you will see the partitions of the data, and if you visualize, if you zoom it in, you can see what's going to be our root node, and you can change the size of the figure to see the visualization properly, to see all the nodes. Okay, so now we have covered 2 simple approaches for regression, and now we are moving to deep learning approaches. So does anyone have any questions so far?